Okay, let's talk about 0.6 rational exponents and radicals. So, what are we up to today? Our skill objectives. We're going to simplify square roots. We're also going to simplify radicals, which are things like the cube root of 3, the cube root, the fourth root, the fifth root, all of those. And then we'll add, subtract, we'll rationalize the denominators and apply some properties of those rational exponents. All right, then we're going to understand that radicals are equivalent to rational exponents. So x to the 1/2 is going to equal the square root of x. We're going to talk more about that and understand that a radical implies one number, the principal root. So the square root of 49 is equal to 7, not plus or minus 7. And we're going to talk about that more in detail in just a second. But first, let's look at the summary page first so you can get all your formulas down. These are the big ones. So if you want to pause the video for a second and get that, you certainly can. Okay, so I'm going to read this whole thing out. Principal square root. Let A be any non-negative real number like 50 or 25. Then the non-negative real number B is called the principal square root of A, denoted B equals square root of A if B squared equals A. So if 5 equals the square root of 25, 5 equals the square root of 25 if 5 squared equals 25, which in this case it does. Okay, so the symbol right here is the radical sign, and the number underneath it, like in this case 25, is the radicand. Okay, all right, so it's important to note that the principal square root of B is non-negative. All right, so the square root of 16 is 4. All right, it's true that negative 4 squared is 16, but we're going to talk about the principal square root, not every square root. So if we say the principal square root, we're not talking plus or minus. All right, you just see a square root symbol from here on out, we're going to be talking about the principal square root. If I want both of them, we'll write down plus or minus. If I want the negative, then I would write negative square root of 49 to get negative 7. Okay. All right, and then for real numbers, you have to square root a positive, right? Because the square root of negative 9 does not work. Cube root would work, but not square root. All right, so evaluate the square roots if possible. 13 squared is 169, so the square root of 169 is 13. All right, fractions, it works just the same way. What's the square root of 4? 2. The square root of 9 is 3. And here we have the square root of negative 36, and so on this one, we would say no real solution. Can't be done. All right, so let's try another way around here. What happens if we're square rooting something that's being squared? Okay. Well, order of operations, we're going to square first, which would make it positive, and then we would square root. Okay, so we're always going to get the positive version. Sorry, go away, Java update. All right, so the square root of 6 squared is 6. The square root of negative 7 squared is 7, because negative 7 squared turns into 49. We do that first, and then we square root it to get 7. And then the square root of x squared, we need to write absolute value of x, because we don't know if x was positive or negative or not. Okay, so the absolute value says get rid of the negative sign. It'll be positive. Okay. All right, so simplifying square roots, we can break things up. So if you are able to multiply inside, you can multiply outside. If you are able to divide inside, you can multiply outside of your radicals. All right, so for instance, the square root of 20 can be broken down into the square root of 4 and 5. Why is that important? Because the square root of 4 is a perfect square. So we get to write 2 rad 5. All right, same thing on this example here with square root of 40 over 49. 40 is 4 times 10, so 2 rad 10. The square root of 49 works out nicely to 7. Okay, so remember your list of perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. All right, so let's simplify these square roots. The square root of 48 could be written as 16 times 3, and then what's the square root of x squared? So we get to write this as 4x square root of 3, right? Because squared and square root will cancel out. Okay? Now, technically on this, we're going to say the absolute value of 4x, but on these problems, I'm going to be okay with you just saying 4x times the square root of 3. All right, so 28 is 4 times 7. So, and we'll talk about the x cubed here in a second. So 4 and 7, we get 2 rad 7. So x cubed could be written as x squared times x. What happens to the square root of x squared? That just becomes the regular x. And this x is still trapped underneath the radical. So we're going to write down all the things that came outside, 2x times the square root of everything remaining, 7x. Okay. All right, so 12x times 6x all under the square root. So let's multiply them together first. So we'll have 72x squared. And then can we break these down? We've got 36, 2, and x squared. So we would have 6 from this part. We would have regular x from this part, and we would get the square root of 2. And lastly here, we do get to divide first. So what's 45 divided by 5? 9. And then what's x cubed divided by x? X squared. So then let's do the square root and say 3x. All right, your turn. Try to do A and B. Correct answers, 2x square root of 15x, and B, x times the square root of 5. Okay, so we'll expand our discussion from square roots to other nth roots. So when we say nth, we're talking about any number. So it could be third roots, fourth roots, fifth roots, sixth roots, okay? All right, so let's look at this. Let A be a real number and n be a positive integer. Then the real number B is called the principal root. So we're looking at this setup here. B equals the nth root of A. Okay, so if n is even and A is positive, then B is positive. So let's look at something like this. These are probably easier to look just as the examples, right? The even root of something even works out just fine. The even root of something negative, not a real number. Okay? But then odds work. So the odd root of 27 is positive 3. But the cube root of negative 125 is negative 5, because negative times a negative times a negative is still a negative. Okay? All right, so we have these properties, and I believe you got these down from the summary already, but if we missed anything, let's go ahead and tack those on. So I'll pause the video for a second and get these, and then we'll talk about the examples. Okay, so simplifying our radicals here. So we're going to break this down in just the same way. It's a cube root, so let's have our list of perfect cubes. 1 cubed is 1, okay, not helpful. 2 cubed is 8, and 8 goes into 24, so let's pull that out. I'm going to pull the negative out with it, because I can do the cube root of negative 8 times the cube root of 3, because 8 times 3 is 24. And then I'm going to write the cube root of x cubed and the cube root of x squared. Why did I pick the cube root of x cubed? Because those are going to cancel. So this turns into negative 2. This right here turns into regular x. And then the rest is trapped underneath times the cube root of 3x squared. All right, fourth roots. So 1 to the fourth is 1. What's 2 to the fourth? 16, and that goes into 32. So we have the fourth root of 16, which turns into 2, times the fourth root of 2, which can't come out, times the fourth root of x to the fourth, which will turn into regular x, times the fourth root of, there's one more x left over. So 2x times the fourth root of 2 times x. All right. Our combining like radicals works just the same way with x's or a's. If I said 6x plus 2x, we would get 8x. If I had 6x plus 2y, nothing can be simplified. Works the same way with radicals. These are all the same radical, so we can combine them. I see 4 minus 6 is negative 2, plus 7, 5, rad 3. Okay. All right, on B, rad 5, rad 7, and rad 3, nothing can be done. So we need to just leave this. This is already simplified. We're done there. All right, C, you need to do some simplifying. 3 rad 5 plus the square root of 20, I can break down into the square root of 4 times the square root of 5, minus 2, 45 is the square root of 9 times 5. Look at these like terms that we have here. So this is 3 rad 5 plus square root of 4 is 2 rad 5 minus, this turns into a 3. These are multiplying. 2 times 3 is 6 rad 5. So 3 plus 2 is 5, minus 6 is negative 1 rad 5, or you could just write negative rad 5. Okay. All right, so D, we need to clean this up as well. So the fourth root of rad 10, nothing goes into that. And minus 2 cube root of 10, nothing works there. And plus 3, the square root of 10, nothing goes in. This is simplified. You can't reduce that at all. Okay. All right, your turn. Combine the radicals. Correct answer. Okay, we're rationalizing the denominator. So when radicals appear in the quotient, it is customary to write the quotient with no radicals in the denominator. So customary. Okay, so we're going to rationalize the denominator unless it's a really hard problem and it's not really that necessary, and I will let you know when that happens. Otherwise, we are never going to let radicals be in the denominator. How do we get rid of them? We multiply them away. So if there's just a single term, we don't need to multiply by the 3 because the 3 is not a radical. Multiply the top and the bottom by rad 10. So the numerator is now 2 rad 10. And the bottom is now 3 times, what's the square root of 10 times the square root of 10? The square root of 10 squared, which is just 10. So we get 2 rad 10 over 30. Reduce that, rad 10 over 15. Okay. All right, the way we do it when there are two terms is we need to multiply it by something called conjugate. Okay, so if you have an A plus B, the conjugate is A minus B. So for B, we got 5 over 3 minus rad 2. We need to multiply by 3 plus rad 2 over 3 plus rad 2. The numerator, if we distribute, becomes 15 plus 5 rad 2. The denominator, this is the difference of perfect squares. So this is going to be 9 minus rad 2 squared, which is just 2. So the final answer is 15 plus 5 rad 2 over 7. Okay. For C, we're going to multiply by the square root of 2 plus the square root of 7. Square root of 2 plus the square root of 7. So in the numerator, we get the square root of 10 plus the square root of 35. Okay. Nothing to simplify there. Over 2 minus 7. Simplify that. Square root of 10 plus square root of 35 over negative 5. All right, see if you can rationalize this expression. And there's your answer. All right, last section we're going to look at is rational exponents. Okay, so if we have a power that looks like this, 1 over n, that is the nth root. So a to the 1/2 is the same as saying the square root of a. A to the 1/3 is saying the cube root of a. Okay? So then the next step is what happens if you don't just have 1 in the numerator. So a to the 3/2 is, from the denominator, square root of a cubed. That's where the 3 comes from. All right, so let's try some of these. Simplify. So 16 to the 3/2 is the square root of 16 cubed. Okay? Now the nice thing with this is we can do it in either order. We can either square root first or cube first. Let's make things smaller first. So the square root of 16 equals 4. We still haven't dealt with that 3, right? So we need to do 4 cubed, which is 64. All right, so negative 8 to the 2/3, this is negative 8. The cube root of that, and then we can say we're going to be squaring. Okay? So either order, let's make it smaller first. The cube root of negative 8 is negative 2. Squared is positive 4. Your turn. See if you can simplify 27 to the 2/3. And the correct answer is 9. Just a technology tip. Here's how you do it in the calculator. You're looking for the caret, and make sure you're using parentheses for your rational radical. Okay. All right, so the properties still hold with a negative. A negative means you're going to be flipping things over. So a to the negative 3/2 would just be 1 over a to the 3/2. Property still holds. All right, so let's see if we can do some simplifying here. 9x to the negative 1/2. So that means the negative, take everything in parentheses and put it in the denominator. So we'll have a 9x to the 1/2 going to the denominator. Down here, the 4 is not touching the negative, so the 4 stays in the denominator, but the x goes to the top, x to the 3/2 on top. Now we have x to the 3/2 over 4 times, this 1/2 would distribute 9 to the 1/2, x to the 1/2. In the numerator, x to the 3/2 over, this turns into 3. 3 times 4 is 12, x to the 1/2. And if we have 3/2 on top and 1/2 on the bottom, we get to reduce them by subtracting. 3/2 minus 1/2 is just 2/2 or 1. So we have x to the first on top, because 3 is bigger than the 1, still on the top, over 12. X over 12. Okay, your turn. And there's your answer. All right, that's it. We will see you in class tomorrow.